Oh, right. Okay. All right. Longest common suffix queries. Hard. Let's see if this ends my streak. You're given two arrays of strings, word container and words query. For each words query I, you need to find a string from words container that has the longest common suffix from words query at I. For each query, you need to find a string from the words container that has the longest common suffix. Okay. If there are two or more strings in word containers that share the common suffix, find the string that is the smallest in length. Okay, so sort by length, or not sort by length, but length is the tiebreaker. If they have the same length, then find the one that, okay, then the second tiebreaker is alphabetical sorting. Okay. Given an array of integers, answer if answer I is the index of the string in the words container. Okay, so return the answer array for every query. For every query in the query array. So A, B, C, D. Oh, these are basically the possible answers. So for CD has the longest common suffix. So none of these have any suffix in common with CD, so just the so since 0 is the common, so it should be BCD. Oh, you're returning the index. Okay, yeah. So index 1 is the earliest one. BCD obviously 1. XYZ. Longest common suffix here should be this one, no? Y is the third one. There's no string that shares a common suffix. Isn't it the longest common suffix? You find a string from words that has the longest common suffix. Isn't the common suffix X here? Hence, the longest common suffix is double. Longest common suffix, what does that mean? You need to find a string in words container that has the longest oh, suffix. I'm thinking prefix, I think. Oh. Okay, suffix. So nothing ends with C. Right. And CD is actually using BCD because, or I see, CD is using BCD because it's the common suffix, and then BCD is the lowest length tiebreaker. BCD obviously matches BCD, lowest common, and also lower length than XBCD or ABCD. And then C has no common. Okay. So word query GH, they're all in common. I think these two are the same length, 7. So alphabetical would be this one, so it'd be 2. A, B, F, G, H. So F, G, H is in common with this thing, so the first one would be 0 here. And then GH is in common, so again I would use 2. Huh. Interesting. So 10 to the 4th, so that's 10,000 words in the words container and query. And each word can be at most 5,000 length. Okay. Hmm. This is something similar to the previous try problem recently, where I do a try tree using I use a try tree using the letters backwards. So what was the try tree again? Find the prefix common array of two arrays. Length of the longest common prefix. Okay, it's the try node one. Okay. Okay, so I think let's go ahead and do an example here. So how would I construct, if I construct the try tree using the reverse, how would what would that give me? Construct the try tree using the reverse. I think so. So D goes to C for all of them with the query. So D goes to C, and then I would need to somehow determine at C which of the three possibilities is the best at the moment. Interesting. It's almost, I would probably, yeah. D. So C goes to D, has a list of the children which are A, B, B, and XB. So if I do it in correct order, so I think it has to be a list rather than a set because the order matters. It has to be a list instead of a set. Interesting. So the list is sorted by length. So if it's D, C, B is the first tie break because that's the earliest one, and then A, B, and then AB is next because it's earlier than XB. Man, this common suffix, I wish they just did a common prefix. It would have been so much simpler. Does it matter though? I guess it probably doesn't matter. I'm going to sort it by, what do I sort it by? Maybe I need to just make the reverse of the word. The sorting is going to be awful. Because if I sort the word, or if I make the reverse of the word, okay, I think I need to make the reverse of the word, and then also sort by, so somehow it needs to convert from like ABCD, BCD, XBCD. It needs to sort into preferably DCB, DCBA, DCBX, something like that. So it needs to somehow convert, sort and convert there. Can I do a list comprehension here? Probably not. Can I just do the, can I convert this into the reverse and then sort? I think that's probably what I want here. I want to convert it into the reverse of the word and then sort. Don't see what the issue would be in that case. I might have to do a second conversion at the end. Probably need to store by indices as well. Although converting it into the reverse is also kind of a pain. That's pretty long strings. Oh, whatever, it's a hard problem. I'm not gonna worry too much about optimizations like memory here. Just need to make sure I get something correct. Okay, so let's go ahead and just do a quick check here. What's the fastest way to find reverse string in Python? I wonder if there's just a function for that. Find reverse string. The fastest, most efficient way to reverse a string in Python is extended slicing. Okay. O of n time. Okay, that's reasonable. I think it's going to be at least that. Since I have to sort anyways, it's going to be O of n log n. So for simplification, we'll reverse each string. So I'll go I really want to go reverse all my things, right? Including my containers and my query. I'm not sure why they call it container. I'll call it what do I call it? I kind of feel like I want to call it dictionary, but that's not it. My answer list, my answer set. I'll call it POS for possible. Possible answers are going to be want to actually store the index as well. Yeah, whatever. Let's go ahead and do k of inverse. So it's negative colon -1 for every k in words container. And then I'll just say queries is k of inverse or reverse for every k in words query. I'll just go and make sure that this is correct. Okay. And then I'll sort it. So it'll be possible. Oh, wow. I think I want this to be a tuple. I want to keep the original index because the original index is what I will use post sort to identify. The original index is to use post sort to identify the original word without having to reverse it. So I'll use, so this k is going to be the index. So it'll be words container at this k for every k in the length. N is the length of words container. So for every k in the range of n. And then this is the tuple that is the reverse word and the index itself. Oh, whoops. Words container at k reversed. Whoops. Okay. All right. ABCD is 0, DCB 1, DCBX is 2. All right, and then I need to sort, right? And then so it would be possible dot sort, and I'll need to use a lambda key or lambda function to sort it here. So key is equal to, so it's going to sort by alphabetical. Oh, if it sorts by alphabetical, then that's perfect because the shortest one is actually going to be first. Actually, is this? Oh boy. Oh boy. It's not going to work, is it? Is it? Yeah, it's not going to work with alphabetical because if this was something like, because A is going to be last in the, A is going to be last in significance of the alphabetical sort, but it's actually first in significance. So for instance, what am I trying to say here? If this was something like AX BCD versus XA BCD, if I were to convert this and think about the ordering, it should be D, C, B. This thing should be prioritized, so it would be XA versus DCB AX. But if I were to use just a tie break of these things, it's not going to work that way. This is a bad example. let's say this was Z. So in theory, it should be AZ is first, and then AX is second, or XA is second. Is that right? AX. This should be ZA. Yeah, something like that. Like this is, if I were to use alphabetical sorting, then this is wrong. So the length still matters. I wonder if I can't sort pre. I can sort post as long as it's, if it's the same length. How would I break the tiebreaker then? Is DCBA 4-letter words, 5-letter words? So the tie break, so if I sort it, the key should first be the length. The key should first be the length, and then the second thing should be the comparison in the original array. So it needs to be like a fresh key that is, oh boy, okay, so I think this might be something like lambda x, where x is the element. The key is going to be the length of the string, which is going to be the length of so this is a tuple, right? Because possible has tuples. So the string itself is, the first element of that tuple, and the length of that is the first element of this key. And then the second part is the actual word itself within the original words container, because I want to sort by alphabetical there. So it's be words container indexed at the tuple element. No, this should be x of 0. X of 0 is the string itself. X of 1 is the index. So word container at the index. I think that's it. And then I just need to do this test case. Okay, so it should be AZBCD, and then it should be XABCD. Okay, so it should be the last one. Okay, I think this is right. Like, this is not in sorted alphabetically based on the original, based on the reverse string, because this ZA is actually before this XA, but it's based on the alphabetical based on the first. Okay. All right. So now I need to construct. Now I need to construct the tri-tree based on the sorted possible. Okay, and I'm going to use indices. A list of indices where the sorted list of indices matter. No, okay, it's actually, it is a dictionary. It's just a dictionary where this is the dictionary. A dictionary where sets of keys are characters. Maybe this should be a default dictionary. Maybe this should be a default dictionary list. I think that might work. Okay. Okay, so let's construct a dictionary. Construct the try tree from the possible array, keeping order. So for every let's say p word, possible word, and possible list, then this is a tuple, right? So I need to unpack the tuple. So the reverse word and the index is this p word. I guess I just could unpack it in here. Okay, so that's the unpacked tuple. Then I need to go through every letter of that word, for every letter in this reverse word. And I think I need to create a tree. I'll just say root. Actually, I probably should do that after I have the comment. So root is equal to try node. Will just be an empty. Yeah, I think it's empty. Okay, so I think I need to have a current node, which is the root at the start. So if I go D is the first letter, then it should just be adding it to the default dictionary. Is it default dictionary of root? It should be a default dictionary of try nodes, really. Maybe I should just make a dictionary and create the node. Do I need to do that? Do I need to do that? Or can I just do try node here? I wonder if that works. Let's go and just do this quick test. Let's make sure the syntax works. Looks like it's doing it. Looks like it's hanging up. Which I guess means that this doesn't work. Because why else would it hang up here? Yeah, it doesn't work with that. Okay. So it's going to be a list. So D should map to, it should go to D and it should go to try node from there. It's not quite right. Let's go to like D needs to map to the list of indices, and D also needs to map to the trinode itself. Is that right? D needs to map to the list of indices. D needs to map to the list of indices. No. It needs to have a list here, like self.indices, where this is occurring. And it needs to map to a default dictionary of trinodes. So maybe this just be a dictionary. I think that might be it. Okay. Let's see if this for every reverse word index, reverse word index impossible, current equals root, letter equals reverse word of every reverse letter. So D, so something like, maybe this should be a while loop, to be honest. Yeah, maybe this should be a while loop. It needs to go down the thing. No, so for every letter in reverse word. Okay, so let's say if this letter is in the current children, if this letter is current children, then current equals current dot children at this letter. No, actually, that's wrong. If this letter isn't in, if this letter isn't there, then create the trinode for that letter. New try is equal to trinode. Actually, I can just say current.children of this letter is equal to new trinode. And then after that, then current equals current.children at this letter. So it goes down the tree into that node. And then it needs to add this index. It needs to add this index into the list of indices. So it's something like self dot or current dot indices appends this node. This index. So D, when it traverses D, it'll, at the trinode of D, we'll have indices of 0, 1, 2, and 0, 1, or, whoops, this is wrong, this should be DCB. Should have index of 0, then 1. And the first element of that list is actually, the first element of that list is actually the correct one, actually. The first time it traverses to this node, that the first element of that list is the only thing that matters. Okay, so because at every possible suffix there is one answer. I don't really care about all the possible answers. I care about all the connections there, but the only answer that matters is that one index. So actually, the index here, I'll call this the P index. No, it's not really the possible index. It's the, I'll call it the A index or the answer index. Well, what's this going to be? Like, why? I mean, I don't know if this makes sense. I don't know if this makes sense. Because when I construct the try node, I probably need to set the index. Yeah, because the first time I see the node that I want to create, that index is the answer index. So maybe I should just say index of that and construct it with this index. Okay, and then I don't need to do this. Okay, I think that might be it. So this thing goes to every letter, goes to, traverses down the tree at that letter. Until it reaches the last letter, and that's it. Okay. Stores the index. Stores the index of the original tree, of the original word list. I think that might be it. So then I go for every query. For every keyword, query word, I guess. Maybe I just shouldn't call this reverse word, it's just a word, right? Guess that's it. So for every query word in the list of queries, then current equals root, and then for every letter in the query word, probably need an answer array. For every letter in the query word, if the letter, well actually, I guess try node is 0. Ooh. Interesting. So this is actually wrong, right? So if there's no matching, right? If there's no matching, then it needs to default into the first index in my first index after I sort my possible list. I think it should be something like possible of 0, the index of that is going to be my default if there's no matching. So if the letter is in if it's in the current children, then current equals current dot children at this letter. So it traverses downwards, else breaks, and then answer appends the current index. I think that might be it. Try node, whoops, A index. I think that's probably fine. Okay. That's a lot of cases. Interesting. So what's going on here? Let's go ahead and print out I'll print out both the possible and the queries. I'll put the queries first. So these are the queries. So interesting. A, huh. So A doesn't match with anything. I must be misunderstanding how the non-matching works. If there's no, so most common suffix is empty. Among the answers, string at the index 1 because it's the shortest length of 3. So there's no matching. UA This is the first tiebreaker. So they're the same length. Why is it 0? G Okay, so the query is this thing. Nothing matches A, right? There's nothing, so there's no common prefix. The tiebreaker is between these two. And then it should be 1. I expect it is 0. Okay. There are 2 more strings. Let's hear the longest common suffix. Find a string that is the smallest in length. If there are 2 or more such strings that have the same smallest length, find the one that occurred earlier. Oh my god, it occurred earlier. It's not the tiebreak isn't just totally misread that. Okay. The second tiebreak is just the occurrence. It's the sorted sort by length and then by the actual index. The index being x of 1. That's it. Okay. Do 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 do. All right, cool beans. Not that terrible. Very similar to the previous try node that was within the last 2 weeks or something like that. Whew. Not broken today. Okay, so reversing the string. Did I need to create this second thing? think I did. Guess I didn't need to sort, did I? Did I need to sort? Uh, I don't know if I need to sort because I need to pass through everything anyways. I need to iterate over all the possible words in word container. If I stored maybe the length of the word, if I stored maybe the length of the word, and if it's the same length, if it's the same length, or if it's a shorter length, then I update the index. If it's the, that might be faster than sorting it, because I don't know if I need to sort. I thought I need to sort because of the alphabetical stuff, but it's strictly trying to find the lowest length and then the lowest index. That's, I don't need to know everything. I think I still need to pass through every possible. So if I don't use the possible thing, if I do a single pass over those indices, I feel like I might be able to do this without sorting, and that would be a big improvement. Because that changes from n log n to n log n, which might be the solution. So yeah, it's gonna be pretty bad if I screw this up. Yeah, it's gonna be pretty bad if I screw this up, but whatever. So let's go for every k in range n. So this is gonna be trying solution without sorting. So k is the index. So I'll say the word is equal to words container at k. I think I need to have something that is root. Root is equal to a new trinode. And I think I need to actually start with some, maybe this should be infinity. Infinity is the length, or index is -1, infinity is the length. Or I can start with 0, index 0, and the length of that, whatever that word is. So words container at 0, the length of that. Okay, so for every index in the words container, I'll call it word is this, and then I'll call it just size. Size is the length of this word. And then I think I want to update the current node. I think I want to update the current node. So if root dot low length is greater than the size, then root dot index equals root dot index and root dot low length is updated to this index k and this size. Current equals root. Maybe this should be inside the if statement or the for loop. I'm not sure. And then for every letter in the word, actually I need to do the reverse of the word, right? So for every letter in the reverse of the word, then it's going to be same process here. If the letter is not in children of the current node, and the current node needs to construct it. And then the index that it's going to use is this index k, and the length it's going to use is this size. And that's it, and then it traverses downwards. Current is equal to current.children of this letter. And in each step of the process, it needs to update the So after it goes to the lower one, it needs to check if the index here is better. If the size here is better. If current dot, let's say, I think this looks awkward, but it is separate cases that I can't really. Else current equals current.children of this letter, and then it needs to update. So if current dot low length is greater than size, then current.index and current.low length equals k in size. I think that's right. So I really don't want to do this if statement again if it's not necessary, which it isn't necessary if I construct it this time. Okay, and I think that's the construction of the tree without sorting. And then it's going to be the same for the answer array construction. So empty answer for every query word. Go to the root, append. Okay, yeah. Queries. Whoops. So I did construct this, but I think I might just, I don't know if it's faster, but I think I could just probably do word query, and then for every query word, query word itself is the reverse of it. Okay, in the original array. Word queries, is it? Words query. Okay, so it worked on the test cases at least. Incorrect answer. Oh boy. Oh, I see, yeah. It doesn't, it needs to match the index. Wait. If it's a lower size, it doesn't do anything. If it's a lower size, if it's the same size, am I not thinking about my test cases correctly here? The only thing here is I think maybe if it's the same size, it needs to go to the lower index. But I'm iterating over the indices itself, so if it's the same size, then I'm just putting a bigger index at that point. Otherwise, I'm thinking of the first index where this occurs. Every k in the range. So I go through, so length of the word. If it's a shorter word, then I update the size and the index that this occurs. Every letter in the word, iterate to that lower letter. Index and size, else iterate to it. Go to that lower letter. Go to that node and then current.index, current.length. Size is updated, index is updated. Over answer. The letter is in keyword. And go to that letter. Otherwise break. Huh. I wonder. A. $47 for the query of A. How long is this thing? It's not particularly long. 47, huh? So I said 47, it's actually 13. So 1, 2, 3, 4, 5, 6. Let's go. How to do this? For every word in words container, I guess I'll just do something. Print the index and the word. Okay. So I said 47, I said 13. 47 is this one. 13 is this one. This one's definitely shorter. No, let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, this is only 6. 47. Wow, well, how did I even come up with 47? It's a single A. How did I come up with 47? Single A. So okay, this is already reversed. So it's a single A, single A. When it came up to 13, I should have stored it there. Why would it store 47 at that point? Why did it update 47? So the letter Wait, what is the size that's using here? Size is the length of this word. Size is the length of the word. The one that does 13. So when it does 13, it's going to go 13 is the word. Is that whatever A, AD, ADC, ADC. So it's going to go, word is ADC, ADC. Doesn't update this, hopefully. And then for every letter, so let's say A, if letter is not in children, then current.children of A is equal to new trinode, where this index is 13, the size is 6. Size is 6. And then it iterates to that node. Else when it does the other one, once 47, ADB, CDDA, ADB, ADB. ADB instead of ADC. So it should do the same thing for A, D, and then when it does AD, the common prefix should have been Alright, I think maybe, how do I want to do this? I think I just want to modify this thing. So I just care about 13 and 47. Now it's constructing this. So 13 was this. 13 was CDA, CDA. And then 47 was second to last. And then I just really care about the singleton A query. So I assume this is just wrong. It's just the code that is getting it wrong. It's getting it right. That is tough. Oh boy. ADC, ADC, wait, is that right? ADC, ADC. Which means that's reverse, right? So CDA, CDA, ADD. Oh, I picked up the wrong one, fuck. No, that's right. ADD, CD, CDDA, yep. Huh. Single A. ADC. Oh boy. There's a bunch of errors as well. My output was 47, its correct output is 13. Lower size, letter's not in there, struct it. So it goes A, I thought children of the letter. Store the low length, store the length. Root. I misspelled low length. What the fuck am I doing? Oh my god. Oh my god. Oh my god. This is unbelievable. Oh my god. And it's still not very fast. Oh, I forgot to delete the print. Come on, this has to be faster. There's just no way this is the same speed. It is the same speed. Okay. Fair enough. I don't know why it'd be the same speed because one involves sorting, one doesn't. Wow, that was really bad. Well, that's Python for you, I guess. Without the declaration of variable names at the start. You just use whatever. I wonder why this is not that big of a speed up from sorting to not sorting. Every word. You do need construct a trie node, a trie tree, I think. Maybe there's a faster way without constructing a trie tree. I mean, if you just did default dictionaries all the way down, but no, that doesn't, that can't possibly be that much faster. So for every letter in the keyword, if the letter is in current children, okay, that's fine. Or this is as good as I'll make it. All right, so summary. Say this is another problem that uses trinode kind of data structure to help organize or help organize the letter information. Trinode tree allows for traversal of the reverse of each word, storing the index of the answer, which is based on tie breaks of word length and index at the earliest for each node. Again, the node is the suffix traversal of the query, and then so for any longest common prefix or common suffix, traverse the node to the farthest that it can, and get the index that is at that node, and append to the answer array the index at that node. So the construction of the node of the tree is you have your trinodes, you'll have your dictionary which maps each following letter to another trinode. So trinode has a root which is kind of the empty node or kind of a blank node. You have a D which maps to C, which maps to B, which maps to A. Kind of this node maps to all the children that has D as the ending suffix, which in this case is just C. And then C, so D goes to trinode that's C. C goes to trinode that's B. B has two children, an X and A trinode. So X goes to another trinode, or B maps to X and B maps to A, or B links to X, B links to A. And then you need to store the index. That would be the answer index, which is the shortest string that hits this trinode as the first tiebreak, and then the lower index within the original words container as the second index, as the second tiebreak. And so yeah, you can construct your trinode here, reverse word. This is just your root needs to have has to have a tiebreak as well. And then for every word, and again this is the reverse of the word, so it's going through the letters in reverse order. Construct a trinode for this letter if there isn't any current mapping for it, and then iterate to it. When you construct it, store the current size, length, and index. Else go to the pre-constructed one, and if this is a better tiebreak, then lower that tiebreak. Yeah. Time complexity to meet O of n. Actually, note that I tried a sorted solution, which didn't seem to affect the algorithm speed for some reason. I'm not sure why. Time complexity of n, since you need to do a single pass over all words. I guess this might be considered O of n w, where n is the number of words in the array. Number of, actually this should be O of nw plus qw, I think. Number of words in words container, in number of words in the word bank of the thing. Q is number of queries, and W is the length of the words. Yeah, since you need to do a single pass over all words and all characters in the word. Space complexity, this should be O of nw, since the trinode tree will have possibly all words kind of as paths in the tree.